All right, today we're learning how to solve exponential equations that do require logarithms. So for instance, we knew before that if I had 3 to the x equals 3 to the fifth, if we had these matching bases, we could say x has to equal 5. Okay, however, if we have an expression where they're not necessarily equal, like 5 to the x equals 7, and there's no way I can make those bases match, to solve for this unknown exponent requires logarithms. Okay, so we're going to talk about how to solve those with logarithms today. So the steps for solving include these. The first thing we need to do is find the base that contains our unknown exponent. In this case, that is 5 to the x power. And we need to isolate that, which means get it by itself on one side. So get it by itself, make sure it's positive and on one side of the equation. So let's go ahead and do that first. Okay, so let's move some things away from 5 to the x. So always get rid of things that are held with addition or subtraction first. So we're going to add that 3 over. Okay, so now we have 2 times 5 to the x equals 20. We still need to get this base by itself, and we have this 2 held with multiplication. So what we want to do is divide everything on both sides by 2. Those 2's cancel, and we get 5 to the x equals 10. Okay, perfect. We've got our base isolated. Step 1 was a decent amount of work, but important step. Next, we need to change this from our exponential form to our log form. And if you remember, when we did intro to logarithms, you can look this up in the notes again, we did some bunch of practice problems of this. So one of the things to remember is the base of your logarithm is the same as the base of your exponent. So as we write this, we're going to say log base 5, okay, that's the base of my exponent, of something equals something. And remember that the logarithm always equals the exponent, which is x in this case. So equals x. It always equals the exponent, right? The exponent here goes at the right. And the value that 5 to the x was equal to is what goes inside your logarithm. So this 10 essentially over here goes inside the log. So log base 5 of 10 equals x. This is the log form of that expression. Now, in order to plug this into a calculator that doesn't do log base 5, like if you're using Desmos, we need the change of base formula. Which remember is just a way where we write this with fractions. Log at the top over log of the bottom. And to do this, remember we drop the base. Base goes in the bottom here. Base goes in the basement. And 10 stays up top. So this is the fraction I can put in Desmos to get my answer. And this is what I can put in some other calculators. Okay, so here's Desmos. Hit / to get our fraction. We're going to do log of 10 up top, which actually has a value of 1, and log of 5 in the bottom. And here is our answer. And it says evaluate the log, round to 6 decimal places, finish solving, and round to 3 decimal places. Well, it already says x equals. So since we don't have to do any extra work, rather than rounding to 6 decimals first, we'll talk about why in a little bit, let's just round to our 3 decimal place answer. So 1, 2, 3 decimal places. We need to look at the 4th decimal place to figure out if we need to round up. And remember, if we have a 5 or greater, to round up. So this is 1.431. We do need to round up this time. 1.431. Okay, so there's our answer. 1.431 is our approximate answer for x. And notice I did use the little approximation symbol because it's not exact. We did have to round it. Okay, so let's try number 2. Same steps. We will have a little bit more to do at the end. But step 1, isolate the base with our unknown exponent. In this case, this is the base e. And that is that new number we talked about, Euler's number. It's kind of like pi, but it's its own different value. But we need to get e by itself. Okay, so the first thing we want to do is divide away that 4 held with multiplication. So we're going to divide both sides by 4. The 4 in the top and bottom will cancel on the left. And we're left with e to the x plus 1 equals the fraction 11/4. Now, if you want to turn that into a decimal here, you can, because it does stop. It's a decimal that stops, right? But we'll leave it as a fraction. Okay, we've isolated the base. It's by itself on this side. It's positive. Good with step 1. Step 2 is change it to log form. So when we write this, remember it's log with a base of, in this case, e, which you might recognize is really the natural log. Log with base e is the natural log. Okay, but base is e, right? The base of my exponent's the base of my logarithm, equals, and the exponent is always what the logarithm is equal to. So in this case, the expression x plus 1. And the 11/4 is what goes inside my logarithm. 11/4. Okay, now log of e, as I just discussed, if you remember this, is the natural log. Log with base e is really the natural log. And so now that we have our logarithm, the natural log, we're going to go to Desmos and find the value of this log. And we're going to go all the way out to like 6 decimals. We're going to do extra decimals. Okay, so I've typed in ln, natural log of 11/4, and here's the value it gives us. So we're going to go out some extra spaces. The reason we want to go 6 decimals or so now is because we don't want to round to 3 decimal places until the very end. If you round early and continue to do math with your rounded early answer, you start to get further and further away from the true answer. So the goal is to not round until the very end, but as long as we keep a bunch of extra places right now, we'll be okay. So we're going to write 1.01160. Okay, I realize that was only 5 decimal places, but that's okay. We'll be all right. As long as we've gone a couple extra places out, we'll be fine. 5 is probably okay. So now we just need to finish solving for x. So that's the last step, finish solving. So x is not by itself this time, right? We actually do need to do one extra step, which is subtract 1 from both sides. So I don't even think I need a calculator for this one. 1 point something 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 minus 1 is 0.0 something something something. That one is probably easy. Equals, I guess I don't need the bar there anymore. Or is approximately equal to x. And then it says to the final answer to round to 3 decimal places, which is the nearest thousandths. So 0.01 is 0.01. Ooh, this 6 though means we need to round up. So 0.012 is our approximate answer for x. All right, let's try a few more examples like this. Okay, example 3. Okay, once again, we want to try to isolate our base with our unknown exponent, change to log form, find the value of the log using Desmos and go out a few extra decimal places than what we want to round to, and then finish getting x by itself if necessary. So if you want, you could try to pause the video, see if you can solve these two now, but I will go into detail. So if you did solve them and you just want to check your answer, skip to the end of the video, because otherwise I am going to go through each of these. Okay, so here we want to first subtract 1, get rid of things with addition or subtraction. Next, we've got -3 times 2 times x to the negative, or x minus 3 power equals -18. Now we still need to get this base by itself. So we need to divide away the -3 that's being multiplied. Okay, those -3's here will cancel. And we get 2 raised to the x minus 3 power equals 6. Okay, and that was all step 1, getting the base by itself. Okay, step 2, change to log form. So remember, we're going to write this log. The base of my exponent is the base of our logarithm. Of something equals something. And the log always equals the exponent. So x minus 3 goes over here, and inside goes 6. So this is the logarithm we're going to go to Desmos and find the value of. Now again, I might need to use change of base formula. So let's go over that again. When you need to use change of base formula, you start with a fraction. You have a log on top, you got a log on bottom, and the base goes in the basement, or drop the base. So here is log base 2 of 6, but in a form where I can put it in, or format where I can put it into Desmos. And so we're going to go out a few extra decimal places here. I said 6, maybe that's unnecessary. 5's probably okay. I'll do 6 this time. 2.584962. Okay, so there's my bunch of decimals that's represented by my log, but now we still need to finish getting x by itself. So in this case, we need to add this 3 to the other side, and we'll have solved for x. So adding these together, this will give me 5.584962 is our approximate value of x, and then let's round to 3 decimal places. So I would cut off here, but we need to look at our 9, which says round up. 5.585 is our approximate answer for x. Okay, let's try our last one. Example 4 here. Again, we need to get the base with our unknown exponent all by itself first. So we're going to add 7 to the other side. And that gives me e to the 2x plus 1 power equals positive 3. Okay, so step 1's done. We've got our base by itself. Next, change to log form. So once again, the base of my logarithm is the base of my exponent. And log base e is really the natural log. So I will write this as natural log in the next step. But remember, as we change to log form, the base of my exponent is the base of my logarithm, and the logarithm always equals the exponent. 2x plus 1 goes here, and 3 is what goes inside. So we need to do log base e, or the natural log of 3. Okay, so now we can go to Desmos and figure out the natural log of 3. Okay, here's the natural log of 3. 1.0, okay, there's a lot of decimals here. 0.98612, something like that. Okay, so we'll write down all these extra decimals for now. Okay, equals 2x plus 1. Well, we still have to finish solving for x. So how do we get these values away from x? Get rid of things with addition or subtraction. So subtract 1. And now if you want to continue doing that math in, say, Desmos, there is a way to tell it what to do with the previous answer. So if you just kind of hit enter, so it goes up to the next line, you can type in ANS. Okay, you can type in ANS, or you can just click answer down here. And what do I want it to do with the answer? I want to subtract 1. So minus 1. Oh, there it is. It was just off the screen. Okay, so there's our answer when we subtract 1. Okay, obviously I didn't need to necessarily use a calculator for that, but I just want to show you how you can continue with an answer. And now to get x by itself, I need to divide by 2. So I can tell it to take the previous answer, and I can hit / for divided by 2. And this is the answer when we divide by 2. All right, so we'd want to divide by 2 there. This is the answer we got from Desmos. We took our answer and divided by 2. And now finally round to 3 decimal places. So we'd cut it off there. 3 means this time we do not need to round up. 0.049 is our approximate answer for x. Okay, if you got both of those on your own, awesome, awesome. Okay, solving exponential equations is a little bit easier than log equations, which is what we'll be doing next time. So hopefully these 4 examples helped. Lots of good detail in these, and obviously we will go over some more examples and any questions in class.